Okay, so I'm Kevin from the SCION Association, so I'm going to come and talk a little bit about the SCION routing technology. Some of you may have heard of this, some of you may have opinions of this, for some of you it may be something that's completely new. But I think that there was a talk yesterday by Dr. Ritesh, I think he's from Nokia. He very well described the routing problems. I think he did it in some depth, so I think that's a very good introduction to this talk. So really what this comes down to is that, BGP has been used for, I think, 35 years, maybe 40 years even. It works very well. It's a very reliable protocol. It underpins the entire global internet infrastructure. But it has a number of issues. Some of those were covered on the talk yesterday, particularly the issues of route leaks and route hijacks. The fact that there is inherently unverified trust in the BGP system, you can address that with things like RPKI, but it doesn't go the whole way towards to address all of the problems. And the underlying problem is that typically sending and receiving networks on the internet can't decide the path that their traffic is taking across the internet. And it can be sent through on unpredictable paths through different jurisdictions. And not only does this cause some regulatory issues sometimes, it does open up a lot of issues with respect to surveillance and compromising security. And for some applications and for some use cases, this is a really important issue that they need to address. Even if your data is encrypted, as hopefully it is across the internet, you can gain a lot, an attacker can gain a lot of information often from headers and where data is traveling to and from. So, you have to sometimes ensure that your data isn't taking a particular route. And then sort of finally, BGP failover is a relatively slow in terms of convergence. And for some applications, this is also a concern. Now, again, this was touched upon a little bit yesterday. It's going to be touched upon in another talk later today, so I'm not going to go into this too much. Obviously, you can do RPKI and route origin validation. And I would encourage people definitely to do that. But that's still only doing origin validation, and it's not validating paths actually through the internet. BGPsec was an attempt to build on that. That's been around for quite a few years, actually. But that has really seen almost no deployment for various reasons. And again, it still doesn't offer you explicit path selection over the internet. That brings us to ASPER, which is sort of an attempt to address some of the issues of BGPsec and make that more deployable. This, I would say, actually looks quite an encouraging development. I think it's very close to being deployable, or it is being deployed now. But again, it still doesn't have this assurances that traffic will follow particular paths. Now, why is this a problem? Well, actually, there's a lot of legacy infrastructure out there. I think we're in a room, I come to quite a lot of network operator groups, and I think the sort of ISPs tend to be in the consumer and industry offering type of thing. But there's actually a lot of older legacy infrastructure out there, particularly in sort of power and transport in emergency services that are really running on some quite old infrastructure. Some of this is not even the internet. So one example is the air traffic control system that's running on a sort of serial protocol. In some cases, this is actually running over MPLS. But often this is running over sort of leased lines, MPLS in lieu of leased lines. Sometimes it's just running over actually the telephone system. Well, I was quite surprised to learn even today. And all of this really needs to be replaced. It's getting more and more difficult to support. It's more and more expensive to support. Actually, engineers are retiring and can't support it anymore. So a lot of these industries are now looking towards actually using commodity internet connections, which they can source quite cheaply and reliably. But they actually need more assurances and control over where their data is actually traveling. They need more security around that. You would be very surprised actually at how the lack of resilience in some of these infrastructures. I think we see this occasionally. You see like whole airports going down. I think, although it's not an internet connection per se, I think the Deutsche Bahn train network, the GSM-R went down for I think 2.5 hours or something like that. So actually you do see these critical failures because there isn't a lot of resilience built into the system ultimately. And that's something that really we need to, in the sort of era of increasing cyber attacks, increasing sort of data sovereignty breaches, that we need to look at and address. But really we need this to be a true inter-domain and multi-ISP type of support, rather than sort of single vendor, single ISP solutions. So this brings us to SCION, and what SCION is. So this is an attempt to really address some of the issues around BGP and some other sort of issues that we might need to address. And one of the things it tries to do is establish trust domains that are self-governing. So in other words, you're not reliant on third-party PKIs, for example. You have control over your organizations, have control over their trust domain. This isn't really a new idea on the internet. There's been various attempts to have sort of trusted parts of the internet that have come and gone, and been various proposals over the years. But this is something that is quite an interesting concept, and actually can be used in certain use cases. I think really the key thing though is the path control. So some of these applications and users and industry use cases, they do need to be able to actually choose their paths across the internet and where their data is actually traveling. You can do this not only really for just usual traffic engineering issues like latency. I think a new idea is to do environmental green networking. But actually the real sort of strong use case is sort of geofencing, for example. So that you can choose which countries and which legal jurisdictions that your data is going through. And then sort of finally, there is the sort of the fast path switching concept. So you'll be able to switch network paths very quickly within 1 or 2 seconds, and also be able to use multiple paths concurrently. You have that control, user control over that aspect. So the basic building block of SCION is something called an ISD, which stands for isolation domain. I think with hindsight, this isn't the best name to have chosen, because it sort of implies that your traffic is isolated from the internet, and that's not really the case. It can be, but it doesn't have to be. But this is a trust domain. So this is set up by a group of organizations, quite often a group of organizations that are maybe responsible for running an industry. So it may be the power grid, for example. In Switzerland, it's the banking sector. And these ISDs are set up and administered and run by what you call voting ASs. So these are the sort of the ASs, or the organizations that are running the ISD, set up and run the ISD. So they actually have a cryptographic signing ceremony where they establish something called a trusted root configuration, which is essentially a Meta X509 certificate. And then that's used to establish a certificate authority that they set up and run themselves. And that does the authentication of the member ASs within the trust domain. So there's usually a policy of how autonomous systems or networks are admitted to the trust domain, and those are authenticated. They're cryptographically authenticated through the PKI, which is under the control of the trust domain. There is this concept as well for routing reasons. There's a concept of core ASs and child ASs. This diagram is not particularly correct. The core ASs would typically be the ISPs that provide service within the ISD. The other ISPs listed here would be more customer networks that are members. So how this is done, so there is a control plane that builds up, that essentially does the routing through building up by discovering links. what we call path segments. It uses beaconing systems. So these beacons travel across the ISD. It sort of raises awareness or signals, how you reach all the connections between all the ASDs. This allows, so within each AS, there is a control service that then will build up potential paths from the destination from the source to the destination. So that's basically how it builds up knowledge and awareness of the network. But it does this sort of in an advanced way, so this is not done on the fly. This is done sort of at startup time, it's done periodically. So the control services in each AS will actually know all the potential paths across a network to a destination. So this means that you can switch paths very, very quickly. Also, all of these paths are authenticated as well using the PKI through X509 certificate. So these are all cryptographically verifiable. Now, in terms of actually forwarding the traffic, that's done over IPv4 or IPv6. You can use both. So it's no change there. Actually, within the ASs themselves, you still run your interior gateways, IGPs. So you don't need to change anything within the ASs themselves. But then when actually an endpoint needs to send traffic from one place to another, they can select the most appropriate path across the SCION-enabled part of the network. So, and often that will be policy-based. So, you may choose that, for example, if your network is in Switzerland, you don't want it to go outside of Switzerland. You may want to keep all your traffic within the EU, for example, for data protection reasons. And you can specify where certain path policies, which don't have to be geofenced. They can be based on other parameters as well. But you have quite a lot of selection or a lot of flexibility in choosing where you want that, which path you want to choose there. Right, so the deployment model, so this is where SCION routers are set up at the borders of the AS, so you don't change anything internally. They peer with other SCION-enabled networks, send and receive traffic, pretty much straightforward. I already mentioned the control services as a control service or control services running in each AS that will discover the paths and map, and then they'll validate those as well. But what you can also do as well, you can connect in legacy endpoints that are not running SCION using SCION IP gateways. So these are sort of translation devices. So you may have end sites that are not SCION enabled. They can come in via a SCION gateway. The SCION gateway looks like a router from the perspective of the SCION network. It looks like a gateway from the perspective of the end site. So that helps you make the transition from legacy networks towards the sort of SCION internet. So on that, it gives you a lot of control over rolling out your networks. It also allows you to sort of connect to the rest of the internet, so you're not cut off from the rest of the internet. You can send and retrieve traffic from the internet. But that's also done based on your ISD policy as well. So you can keep all your traffic within your trust domain, or you can choose what traffic to send and receive from the rest of the internet. And that's sort of a very powerful thing to use for things like critical infrastructures where they may really want to restrict where their traffic is going and what traffic can come into their networks. But equally, you have flexibility to connect to other networks as well. We should also mention that you can interconnect the trust domains as well, so you can interconnect the ISDs. So again, you might have a banking network in Switzerland, you might have a banking network in Germany. They can mutually trust each other and send and receive traffic between those two ISDs as well. So it's really the choice of who is running the ISD, how they deal with the traffic. Okay, so it's often said SCION is, it's a research project, it's for research institutes. Actually, this is certainly not true. There is actually real-world deployment in production networks, largely in Switzerland, but this is increasingly expanding beyond Switzerland. So The sort of first production network was used, it's called the Swiss, Secure Swiss Finance Network, SSFN. And this was set up by the Swiss National Bank and the Swiss financial services provider called SIX. It's actually the stock exchange as well. They provide financial services in Switzerland. And really this was to replace an old MPLS-based network that was becoming more and more expensive to build, to maintain. So they chose SCION to build their new network. And this is actually used for all the banking transactions in Switzerland, all of the 300 or more than 300 institutes across Switzerland. This is used every day in production environment. It's a reliable, and secure, network. So why did they do this? So this was originally built, the original network was built on point-to-point private circuits. So these, were quite predictable. You knew where they were running, you knew where they ran to, but this was just becoming too expensive to maintain. The whole banking network was growing, particularly as you have more and more terminals in sort of remote places. It just wasn't scalable anymore. It was becoming too expensive. But there was also a resilience problem as well, to actually build in a lot of resilience, you have to add more and more circuits, and this was just becoming prohibitively expensive. So the management was becoming complicated, the cost was rising, it just wasn't a viable option anymore. So they were also offering MPLS. This is a bit, makes life a little bit simpler, of course. MPLS is well used and well understood. But it is often heavily reliable on single operators. It was in Switzerland. They wanted to actually go out and use more ISPs. I think there's 5 ISPs in Switzerland at least, so they wanted to have the option to use other ISPs. But also, again, MPLS is not really good for supporting lots of edge locations and remote users. So that was another rationale that there's more and more remote workers in banks, even in the Swiss National Bank. So they wanted to support a lot of these remote sites as well. So this wasn't really a choice for them. And also, there's a more and more awareness of the whole third-party and supply chain risk management. I think NIS2 has focused a lot of minds around that. And you actually find that there's been quite a few outages of MPLS-based networks in these sort of critical infrastructures. So this is sort of another reason why they looked at SCION. So SD-WAN is also an option. So this is really, allows secure private networks to be built over commercially available ISPs. This is a good option, actually. It gives you some more resilience, and you can do things like traffic prioritizations and gives you some cross capabilities. But again, you're still reliant on the underlying internet infrastructure. So you're vulnerable to DOS attacks, the same. You still have this limited path control capability, which is actually the key underlying issue here. And then there's just generally, vendors have their own proprietary standards, which create some vendor lock-in as well. There's sort of interoperability and vendor lock-in issues around that. So that was a reason why that wasn't, was essentially ruled out for the SSFN. I don't know if segment routing was actually ever really considered for the SSFN, but this question comes up in these environments quite often. Why don't you use segment routing? Well, yes, it is kind of can be a solution. But again, it's reliant on MPLS and IPv6 networks. But it's also quite complex to manage as well. You need to have an understanding of the underlying infrastructure. There's a lot of coordination involved around this. So that was, I think, one of the reasons why this wasn't considered. So that kind of brings you to SCION. So, what SCION does, it is an open protocol, and it has multiple vendors and ISPs, it's supported by multiple vendors and ISPs. You can build your trust domains, which is really important for some industries. You have that path control capabilities, and you can do multi-pathing as well, and it's quite fast to fail over, which is an advantage in some, for some applications. But the really important thing is it gives you the choice of how you send and receive your data. You can contain your data within your trust environment, or you can you can link to other trust environments. You could send and receive data from the rest of the internet. It gives you that control, what we call optionality over how you build your networks. Okay, so it obviously wasn't smooth sailing. So, you know, I think we need to be honest about this. When you're deploying a new technology, it doesn't always go smoothly. But it did go quite smoothly. It wasn't, you know, it did actually result in quite a few technological benefits and quite a few cost benefits as well. Really, the difficult part was around the crypto stuff. So actually establishing the PKIs, doing the key signing, and actually this was done during COVID as well. So it wasn't very easy to get everyone in the same room to actually do the key signing stuff. It did sort of highlight the fact that certificate revocation is not possible, but the certificates are generally limited in operation to 72-hour validity. You can change that, you could reduce that, but that was sort of chosen as a good compromise. Of course, you just sort of discovered some issues in the SCION routing. These were quite a new technology. I think the inter-ISD path control still has some limitations, so it works quite well within the trust domain environment, but between the ISDs, that hasn't really been done to a great extent. It's been done in the research environment, but generally it's been you know, has lived up to its expectations. It's just there's been a sort of, you know, that as anything crypto, it can, you know, cause some issues, but that's been sort of the main you know, challenges, I would say. So this is not just restricted to the SSFN. There's actually other networks that are using SCION. So the FPOS networks, all the payment terminals, you know, you tap on your machine with your card. This Swiss network is using SCION, so it's really good because you have all of these really sort of remote sites, thousands of them, I think, if I remember. You know, and you can have a SCION connection to each of those. And actually, one thing that I forgot to mention is actually there is an SDK now, so you can build SCION into your end stacks as well. So this isn't, you don't necessarily need gateways anymore. You can literally build this directly into your devices, and it will provide a native SCION connection. The healthcare network that connects the Swiss hospitals and doctors is using SCION. Actually, they're using a lot of the SCION gatewaying as well. So you know, obviously, there's a lot of doctor surgeries are still using the standard internet connections. They connect in through gateways, but then the sort of central core network is SCION based. And that was actually the second SCION network that was built. More recently, the power utility company, or the Association of Power Utilities, has been using it. So they have a variety of, a lot of control devices, you know, to control things like wind turbines, solar panels, which are all distributed. So this isn't, you know, the power generation facilities are not, you know, sort of in central, in a few places nowadays. It's distributed around the country, all around you know, Switzerland. So, you know, SCION is very useful for this to, you know, provide that sort of security to all these control services for the electricity generation. But then, of course, you've got a lot of IoT devices in homes, like smart meters that need to be, you know, need secure connections. So this is really quite a sort of an interesting ecosystem that's being built. You know, really sort of fully integrated, you know, wide, you know, quite a wide variety of different types of uses. And then sort of finally, you have the SCION education network, which runs across quite a few countries in the world, in Europe, North America, Latin America. I think Brazil's got a connection, and then some in the Asia-Pacific region, like Singapore and South Korea have connections. So this is using, you know, this is really sort of a lot of, where a lot of the research and testing and the new features are tested. Okay, so this is all very nice. You know, we talked a bit about the technology and some of the technological benefits, but you know, we increasingly got the question, you know, okay, but is this going to pay for us? So we did a bit of a study on this. So we looked at the SSFN and, you know, what were they paying for their network connectivity and their MPLS connections before, and well, their lease lines as well, compared to what they're paying for SCION now. And it's actually really positive, and we were really surprised by these figures. So the return on investment is based on 3 years, incidentally. So in terms of the leased lines, this returned the investment in 1 month. So these were expensive, the leased lines. By replacing them, you were saving sort of 91% of your costs. So it was really positive there. Even for the MPLS, it was a really good rate on the rate of return. So this has paid for itself in a very short amount of time. For the branch networking, obviously you've got more user support there. You've got more challenges because a lot of this will also be using SCION gateways. So the return on investment there is maybe not quite as high, but actually there are still cost savings there that make this worthwhile. And then sort of finally the sort of remote access stuff. This is much harder to really estimate. So this was a kind of tough one. So with this, it was somewhere between 9 months and 12 months you got your return, you got your money back if you use SCION. So it gives you some figures, and this is just one network, of course. You know, it is the biggest use case of SCION, but there's some quite interesting figures here. So I mean, if there's something you're interested in, I would really encourage you to go and look at this report. Okay, so as I mentioned, this is not proprietary. So we really want to encourage more vendors to come into the market. So this is why we went through this ITF process. So this has been quite a long process to actually document all of the SCION specifications. I've personally been involved in this, so I've been writing some of the internet drafts. So these are documented in 3 drafts. There's a PKI, a control plane, data plane. And this is currently now in the RFC publication queue, so these will become RFCs hopefully in the next 3 or 4 months. So this is an open specification that anybody can build an implementation to. There's not proprietary at all. So at the moment there are there's actually more implementations, but there's 2 main implementations. So there is a commercial provider called Anapaya, which is providing most of the boxes to the SSFN, SSHN, SSUN, the ones that are used in commercial or used in production environments. But there is actually an open source version as well, which is used in the research network. It has been used in other implementations. I believe there's a few small commercial providers that are using this, building implementations for sort of customer devices. And actually, it's also used in some end devices for like in the defense industry as well. So the open source is freely available. We'd encourage you, anybody can come and take this and develop this further. So it brings us to the SCION Association. So this is who I'm working for. So we are a not-for-profit organization. So we're here really to try to be the custodians of the open source software. We're the custodians of the standardization process, writing the specifications down to ensure that other vendors can come into the market, and also doing a little bit of the sort of technology awareness as well. So we're not selling anything. We're just trying to sort of raise awareness of SCION, raise awareness of some of the issues with routing, and provide some of the tools that can help deploy this. Okay, so there is some of the organizations that are using SCION at the moment. So in terms of service providers, there's quite a number of ISPs that are starting to offer this. There's quite a few users, and then of course we've still got this all started in the research environment, so there's some key researchers' involvement there. Okay, that was my last slide. If you're looking for more information, I encourage you to go to the links. I'm open to any questions.
Thank you very much, Kevin. That was really good and in-depth. Opening up the mic for questions. We've got someone on Slack? Oh, we've got one at the back already. Simon.
Hi, Simon Lockhart from Bogons. Looks great, but it smells to me a little bit like SD-WAN with a different name. great for private networks with a little bit of tunneling over the internet to connect those networks together. Is that not what it is?
Well, so it can have some of the advantages of SD-WAN for sure. I think its strong use cases is in ecosystems where they have particular need for trust and path control. So you could make that argument, but I think this is also will work over multiple ISPs and will support multiple implementations. And I think ultimately it's when you start, there is a sort of initial technological challenge to start this up. But once you've done that, actually you've got the building blocks in place. It becomes much simpler then to to sort of do your interactions between your different trust domains. So at the moment in Switzerland, they are sort of somewhat isolated ecosystems. But let's say you wanted to connect the Swiss banking network to the German banking network. This is where I think a lot of strength will come into it, because you can sort of have some mutual trust there. That can be sort of different levels compared to what you have within Switzerland. But I do think when this expands beyond single industries, that's where the strength will be.
Okay, and that sort of leads into the follow-up question. You sort of described this as secure pathware internet routing or routing. Obviously, for that to be the case, it's going to require vendor buy-in from the big internet router vendors, Cisco, Juniper, Arista, etc. Yeah. How well are they taking this?
They're interested. So we've talked to all of the big players, most of the big players at least. They know about it. In a couple of cases, they have come close to building implementations. It's the issue of chicken and egg. So we need the customers before we build in the implementation. The customers are saying we'll adopt it when there's more than one vendor implementation. So, I think we're sort of getting there because the interest is growing. We're getting sort of requests for information. We're talking to more vendors. About how can they implement this. So, yeah, you're correct in one sense, but it just needs someone to take a bit of a leap, I think, and that will help a lot.
Yeah, absolutely, because you see quite a few new and innovative ideas coming up around routing technologies and things like that, but they all seem to end up falling by the wayside. Yeah. When it gets to the sort of implementation stage. Now, you've gone one stage beyond that because you've got a reference implementation, but it's getting that sort of multi-vendor interop and all that sort of stuff that becomes the challenge.
Yeah.
Thanks.
I've got a couple of questions in from Slack. The first one is, doesn't this mean that one bad actor inside an ISD now has been trusted to mess up all the networks in the ISD?
So, I mean, that could always be argued with any sort of network. But if that happens, I mean, you have the option. So each ISD has the option to, for example, disable traffic to that AS. It's not sort of although there's a sort of common routing policy, it can be on a per AS level as well. So you could actually sort of turn off your connections to the bad actor, or if there's a bad actor misbehaving, you can adjust your what you accept and what you send.
Okay.
Hi, Pete Stevens, Mythic Beasts. It looks like the zone is defined by the AS number, and you also claim that you have geographical isolation. Yeah. So your Swiss bank might use Swisscom, and your German bank might use Interlink, and they're both mutually present on the London Internet Exchange. So can't your traffic then go through London and skip your geographical certainty because AS numbers aren't in one geography?
Right, so the first thing to say is, although we talk about ASs, these are not ASs, BGP ASs. These are actually SCION ASs. So again, it was a little bit of an unfortunate naming. So they actually have their own unique AS numbers. They can map to BGP, and in fact, they do map to BGP, but they are distinctly separate. But the second thing is, so that you're quite right. So yes, SCION is one step to say, you can, in principle, do your geofencing, but part of the process of admitting organizations or provide, in terms of vetting the ISPs, you would need to sort of check where is that traffic actually going. So that would be part of the governance of the ISD, and you would certainly need to do that, I think, yeah. Whereas your part of the process of admitting an ISP to your trust domain would be, okay, we need to know where your traffic would actually go or potentially might go.
So a large ISP joining in would have to be lots and lots of system numbers in SCION, because they might operate in 200 jurisdictions, and each one of those would need to be individually admitted with their rules.
Sorry, I didn't quite hear repeat.
So, I run a small ISP. We're in 3 different countries.
Yeah.
So I'd actually have to join in 3 times. So one of those is geolocated to Europe, one's geolocated to the UK, and one's geolocated to the US.
Yeah.
And that's 3 different systems that have to join into different groups.
That's a good question. Yeah, I think the thing is that I suppose what's envisaged is that when SCION is enabled on the networks, particular ASs would be, because again, you need to, SCION AS is not necessarily a BGP AS. So you may well need to do that partitioning between different jurisdictions. But again, it isn't a one-to-one mapping between a BGP AS and a SCION AS. These are actually separate things.
Okay, thank you.
Hello, perhaps a difficult question for an organization based in Switzerland, but has there been any interest from NATO or from any of the military alliances in using this technology?
Yep.
Which may drive adoption?
Yeah. So we've been talking to NATO. We've been talking to them for about a year. So actually the Swiss military have been using SCION. They've been using it in military exercises with NATO. They actually have developed an SCION stack for end devices. And we have been talking to NATO. This obviously has, I think SCION is a very strong use case for defense. Because they have real requirements that traffic doesn't go across certain jurisdictions. So actually we've done some demonstrations at NATO events. With the military, it's very long technology approval and procurement cycles. So it's a long process, but certainly, yeah, we're definitely talking to them.
Hi, Tim Bray, Independent. If you presume that this works and it goes forwards and it's into hundreds of ASs, hundreds of SCION ASs in a few years, will you not be in the same position as the current internet where you have potentially thousands of operators and then it will just be the same problem that there's too many to keep track of, and who do you trust?
Sorry, could you repeat the question?
If you presume that this works and is successful and has vendor support, and in a few years' time you have thousands of people with SCION ASs, will you not have something that looks just like the current BGP ASs now, where you still have too many people to trust to work out who's who, and you would be better just trusting the current networks?
Okay. Well, again, as something grows, the trust in principle diminishes. But one of the things with SCION, I think that what's envisaged a lot for the ISDs, these will be for sort of very specific industry use cases. So there will be, financial networks, there will be power grid networks, there will be military networks, which would have some degree of inherent trust in terms of admitting your ASs, but in terms of governing those ASs. You're quite right. As the network grows, how do you maintain that trust? But again, one of the things with SCION is that because this is all cryptographically verified, ASs even within an ISD can turn on the trust on and off of other ASs within that. I think you've got some flexibility there. If something does become untrusted, you can sort of remove that from the trust domain.
Excellent. Thank you very much for the questions. I think we'll have to wrap it up there because we've got the coffee break. So
I'm around. So
yeah, exactly. So maybe catch up with that last question. Sorry about that.